Okay, let's do it. Hey everyone, thank you very, very much for attending. This is the Geospatial AI workshop. My name is Jeffrey Gillen. I'm coming to you live from the University of Arizona Science and Engineering Library. It's 10:05 Arizona time. Thank you for attending from wherever you might be. I know some of you are on different time zones, so we appreciate you showing up. Um, my name is Jeff, and I'm a researcher and data scientist here at the University of Arizona. I also have a little company called Gillen Geospatial, where we do aerial mapping and data analytics. So you found yourself at the Geospatial AI workshop. This is a three-part workshop series. So it's today, and then next Thursday, September 11th, and the final session is the Thursday after that, which is September 18th. So today's session, you can expect it to be, I scheduled an hour, but I gave this talk last week to a different audience, and I think it might go a little longer. So if you need to jump off after an hour, that's fine, but chances are this could go for an hour and a half or something like that. Depends on how chatty you guys are. And if you guys want to, say things, then we'll just keep going with it. Um, so today's session will be kind of three distinct parts, and I'll tell you about those here in a little bit. As we go through this, I want everyone to realize and understand that I am not a deep expert at any one of these topics. I'm kind of like you, I'm a geospatial guy, but I don't have like a deep background in machine learning or AI. I've come to it the last 3 or 4 years. I've been really curious. I've been trying to follow along what it's doing and how AI is impacting geospatial, but I don't have years and years of like machine learning under my belt. So any kind of technical questions like that, I might be just like, I don't know. Let's explore that together. So that's kind of my background. What else? So we're calling this the Geo AI landscape. So let's turn the share back on. Okay, the Geo AI landscape. So yeah, it's going to be an hour and a half. We'll see how long it takes. The purpose of this is just kind of give you an overview. So this will be more kind of lecture based, but we will have time for questions and discussions throughout. I do have a colleague, Carlos, here who could probably field some questions in the chat if you guys have things. So you can put your questions in the chat if you would like. So let's define GeoAI in this case. That word has been kind of been thrown around a lot in the last couple of years. I try to define it pretty simply. So when we say geo, I mean geographic information systems, GIS, remote sensing, spatial analysis, spatial science, that kind of thing. And then how can it be augmented or enhanced or altered or improved with artificial intelligence? And AI could be machine learning. You can kind of use those terms interchangeably. Um, yeah, so that's kind of how I'm defining it. Nowadays, a lot of it's large language models, right? ChatGPT and others, and then how are those technologies being applied to what's going on in GIS and remote sensing? So that's kind of what we're going to talk about today. The next two sessions will be more hands-on and technical, and later on in today's session, I'll talk more about them and how you can prepare for them. But today you can kind of just sit back and listen to kind of an overview. Um, yeah, GeoAI. So for those who don't know or not really involved, the AI revolution is really hitting software development first. People that write code, people that are involved in the development of software are really seeing their industry change. And because GIS, remote sensing, a lot of that is what is software. There's going to be massive implications to traditionally how we've done GIS, how we've looked at data, looked at imagery in a geographic context. So yeah, so these changes that are happening to software are happening to GIS very swiftly. This is coming and it's here right now. So the topics, we will talk about large language models, right, or multimodal models. And as I go through it, I'm going to start with kind of simple to complex. What are the different use cases, or how are people using these LLMs for geospatial stuff? So we'll start simple, to more complex, and then we will go increasing in autonomy from no autonomy to what's just baked into the model to more autonomy. The agents are actually doing things, are actually taking action in a computing environment. And so as I go through, I'm going to have a little AI autonomy meter and kind of talk about what that means for each kind of level. So that's one topic. We're going to take a little break, ask some questions, people can discuss a little bit, and then we'll move on to the other topic of imagery analysis. You could also call that computer vision. And so here we're going to kind of move away from large language models and talk more about machine learning models. And my specific world is about imagery analysis. So I have a lot of bias with high resolution imagery from an airplane or from a drone. And so a lot of my examples will kind of might have a lot to do with that kind of high resolution imagery. All right, so we'll talk about the basics of what's happening with machine learning for imagery analysis. We'll talk about remote sensing foundation models, which are pretty interesting. They've really come online the last 3 or 4 years. And then we'll talk about the open ecosystem. So I used Esri products for a long time, 15 years, but I've kind of gotten away from it now. There's a whole world outside of ArcGIS, and most of it is free to use. You just kind of have to be shown exactly, kind of how the tools work. But there's this amazing open ecosystem, free and open software, and ways to collaborate with people doing geospatial stuff. So hopefully I can show you how to get started with that a little bit. And then we'll finish with where's GeoAI headed? I don't know. I have some ideas of where it might be headed. And so throughout, like I said, I'm not the expert, and I want to hear from you guys. I want to learn from you guys, and let's make this more of a shared learning experience. Let's call it that. Okay, so I'll start with multimodal large language models. So these are the things that have sucked all the air out of the room, they're getting all the media attention, trillions of dollars combined are going to these large language models, right? The ones I have on the screen, I think, are pretty much the ones that are out there. These are extremely expensive and require extreme expertise to make these. Not many people can make it happen. And so they're the ones you probably all heard. There's OpenAI's ChatGPT, Anthropic's Claude, Google's Gemini, X's Grok. Meta has their own AI. I think they've come out with an interface called Meta AI. And then there's DeepSeek from China. There's a few other open source ones like Mistral, I believe. But for the most part, there's like 6 or 7. And so any other software out there that's AI this or AI that, most likely they are first using the LLM capabilities of these major companies. So yeah, I'm using all of them. I haven't used Grok, not used Mistral, but for all the other ones I've kind of taken a look at, and there's a lot of similarities. They're all, they really are all in competition to get stronger and faster and more capable. So you can kind of jump from one to the other and kind of see what they can do. So it's very interesting to see this field develop. All right, so let's now go through kind of different levels or different kind of modalities, I would say, of how people are using LLMs for geospatial stuff. Right, so the first one, I like to call it the AI chatbot, is a geospatial advisor. This is typically how most people are using these large language models. The autonomy level is at none, so you're not there. It's not really doing anything, not taking any action. It's just you're asking it questions and it's repeating the information, usually in a web interface, right? So these chatbots, though, they have a lot of knowledge on geographic stuff. They know geographic distances, they know coordinates, albeit may not be perfect. For instance, they know the distance between Phoenix and Tucson is about 110 miles. They have basic kind of map knowledge. And they have deep knowledge in a lot of concepts of GIS, spatial data, and remote sensing. And so you can ask it just all kinds of questions about, tell me about this technique or that technique, or they really have a lot of knowledge baked into it. So in and of itself, this is a revolution. This is a small revolution, but I think it already is. Instead of just surfing the internet and looking for websites that tell us what we're looking for, these things seem to kind of aggregate all the knowledge of the website and then can just talk to you conversationally. And so I use AI as a geospatial advisor daily. They also have deep knowledge of software tools. They could give you a pretty good tutorial of how to use ArcGIS Pro tools, how to navigate through QGIS, how to write code or commands in GDAL or any other kind of geospatial software. They sure know what they're talking about. Might not be perfect. It might say something silly now and then, but for the most part, extremely, extremely useful. And since I've been using them for about 3 or 4 years, I've seen the progression of how just better they have become. When it first came out, I'm like, it just made up a Python library package that doesn't exist. That's really rare now. Usually now if you ask it to help you do something, it might not be perfect, but it's pretty spot on. Okay, so yeah, that is the geospatial advisor. I think a lot of people kind of use that as their low-hanging fruit, the easiest thing. And then the next one is AI writing code. Okay, so again, this is not really autonomous. So our AI autonomy level is at none. Um, wow, AI is incredible at writing computer code. And to me, this is what I'm using it for. I mean, day in, day out, writing code is extremely hard. I've been trying to do it for 20 years, and it's been the last 3 years where I've just like just taken off in my ability to do things, largely because I have an AI that's just my buddy next to me, helping me understand the concepts, helping me actually write the syntax. So it has freed me from the struggle of this one line of code that would take me, a day to write. And now I just don't even think about it. Now it's just like it writes it. Um, so if you've never written any code with AI before, please give it a try. So you can prompt it with simple things like, "Hey, I need help writing Python code for doing deep learning object detection and aerial drone imagery, and I'd like to use the Deep Forest Python library. Can you suggest a basic Python library for predicting tree crowns?" Okay, and if you've used these tools before, this might look familiar. Uh, it's very good at writing Python code. I mean, that's probably its greatest strength. It can write about anything else too. It can write in Shell. It can write in JavaScript. It can write in R. It can write in pretty much any kind of computing language you might be using. At least all the ones that I use. Again, this is a revolution to me. This has made things different than they were 3 years ago. Really different. So what is this doing for us? Well, yeah, it can generate code in about any language you can think of, but this is still the modality of copying and pasting, right? You're asking questions in a chat window, you're getting a response. If you like the response, you copy it, put it into your code, hit run, see if it works. All right, I still work mostly in that modality. It lowers the barrier of entry to make custom analysis, custom workflows. Suddenly, all these things that would take me weeks or months to do, I can now do in like a morning or an afternoon, and it's stunning. Um, it opens the door for analysts to do more sophisticated analysis quicker. So if you are a pure beginner or someone that's, like a journeyman, you have some experience, it can just level you up and kind of, and help you do you know, help you do what you might want to do, but couldn't really kind of figure out the technical chops to make it happen. And along the way, it writes code, but it also explains it to you. So it is the best tutor of technical computing I've ever had. I mean, there's no way I could find a teacher better than ChatGPT in terms of helping me understand computing concepts and apply them in actual code to do things. Okay, so those non-autonomous kind of low-level uses, I mean, to me, they're absolutely revolutionary, and that's what most people are probably using, ChatGPT or Gemini for or Claude. That makes sense. It's kind of lowest hanging thing. It's the easiest way to get going, and it's It's very useful. So let's go up a level in autonomy. So now we're at low level. All right. So now the drone, or not the drone, I'd spend too much time with drones. The AI is actually reaching out to the internet or other things to do things. So the AI chatbot for information retrieval. To expand their knowledge, chatbots can be given sources of information such as the internet, um, data APIs, or documents. And this is baked into most of the AIs now, and you don't even know what's going on. When ChatGPT first came out, it could only answer what was in its training data, and like that's it. But now it reaches out to the internet. It knows what's going on, current events. It can, search the web. And so a lot of the time you're not even noticing, but yeah, the AI is reaching out to the world to do things. Besides the internet, you can give it data APIs, you can give it documents. So here's an example, which I think is really powerful. You can do a specific query in OpenStreetMap's data API, right? So ChatGPT has a lot of baked in knowledge about geography, but maybe not perfect. Maybe it's not quite right. It mixes things up, but it can query a data API that has all the correct information. And so that's just, again, another revolution that you can give it correct information. It can read through that information and give you the correct answer. When it comes to documents, I'm sure a lot of people have done this. You can just drop documents into Gemini or ChatGPT, and it will read through those documents. It's an expert immediately, and it can tell you anything about them. My favorite app to do that is Notebook LM, which is a Google product. So please check out Notebook LM. Like most Google products, there's like a free tier you can use to get the idea of what the product does, but you can give it all your documents, and then when you chat with it, it's restricted to just the documents you give it. And so it's not going to reach out to the internet. It's not going to hallucinate with some baked in training data that's not true. Um, thank you, Carlos. But yeah, so this is relieves a lot of the issue that people have is that how can I trust it? You can trust it by giving it the documents that you trust. And then you have this thing that can read through all your documents. Um, I like to tell grad students, like, this is the best literature review tool ever created. It's almost too good. I mean, I feel like we might be outsourcing our brain here a little bit too much, but whew, wow, it's really neat. Okay, before we get going on to the next level of AI autonomy, um, I'm willing to take a question or two, or if there's anyone that is using LLMs or anything specific geospatial, uh, we can entertain that for a few minutes. Anyone like to say, hey, I'm using Gemini for this or for that, or if anyone have any questions so far? Okay, I'm not hearing anything. Oh, there we go. Yes, Ross.
Yeah, thanks, Jess. Can you hear me okay?
I can, yeah.
So, one thing that I started using a couple months ago is you were talking about how a lot of if you're using, ChatGPT for writing code, it's a lot of like copy and paste. And that was kind of my entry point as well. Um, I started using this IDE called Cursor. That's
Yeah.
basically VS Code with a LLM agent baked into it.
Yep.
And man, that's been if using ChatGPT to write code was a game changer, this has been like another taking it to the next level because it can actually see all of your HTML doc or what all the files basically in that directory, and it has the agentic power to like create its own files, and yeah, it's like you can literally create entire apps like by writing detailed prompts in a few minutes. So that's just one way that I've been using AI the last couple of months is um, through Cursor.
Thank you. Yeah, we were just about to get into the agentic thing. Yeah, that's next level. So yeah, thank you very much for your comment, Ross. Yeah, so let's keep on rolling, guys. And yeah, here we are, AI agents. Thank you for the intro, Ross. So previously we did we're just question and answering, right? With the AI and usually a web interface. And when we go to the next level of autonomy, now we have agents. And what are agents? They're actually doing things instead of just giving you a response. They can actually take action on your computer, across the web. Uh, you know, the possibilities of it seem endless, both like in an excited way, but also in a very scary way. It's hard to know what where this is going. So an AI agent is a reasoning LLM that has access to a variety of tools and can execute commands semi-autonomously or autonomously. I don't know. These tools could be your local operating system, software apps, the web, databases, data storage. Think of like the entire computing infrastructure, all the software we interact with. All of that could be accessed through agents, through English interface. All right, so this is the opening credits for the TV show Westworld. Okay, I don't know if anyone's a fan, but um, I'm showing this little clip because you're playing the piano and then you let go and the piano is playing itself, and that's why what I feel like this is kind of happening now is you can see it starting to make its own decisions and do its own thing, and again, scary and amazing at the same time. And yep, a great lead into the different types of agents that are out there. So these are not specifically specific to geospatial. These are just agents that people are doing to write software, write code. Windsurf, Cursor has become really big in the software industry. I think most like software companies are using it. ChatGPT has an agent. I've been using Claude Code, which is an agent you put directly into your terminal. And so it has access to your terminal, right? It can read over an entire software repository, tell you everything about it, and then actually execute. I was using it yesterday to help me write a Python script, to take that Python script and put it in a container. Now take that container and put it into an Argo workflow that works on cloud infrastructure. Okay, without an agent or without AI, that might take me like months, at least weeks to do. And that's something I can do in like a few hours or morning or something. Yeah, it's pretty incredible. Replit. Replit is a commercial website, commercial company where we can make web apps, web applications, all just through prompting, all just through English prompts. Um, Not saying this stuff is perfect, but man, it gets you real close. and, and so it can get you 95% of the way there. It still helps to kind of understand what is going on. I have not truly like gotten into the agents because I'm still holding on to the I want to understand what I'm doing and understand the architecture, and I want to be knowledgeable of what I've created. And once you turn it over to the agents, I mean, yes, they will show you the code, but it happens so fast, you don't really know. So it's a different mindset. It's, do I need to understand every single piece of this, or can I just kind of outsource it to the agent and it does it? Hey, it works. Maybe that's in some cases, maybe that's all people want is a functioning whatever, functioning piece of software. Um, yeah, so it's kind of early days with AI agents, but you see the kind of the spark of magic of what it could be, and yeah, it's interesting. I'll say that. Okay, yeah. What was the question? How do they deal with it? Each one's going to do it a little differently. Um, Usually, when you install it, you give it a lot of permissions, and usually when the agent is doing something, it asks you permission. And we'll see when I do some demos in coming weeks. So next week we'll do agents and QGIS and Earth Engine, and one of these, yeah, it usually will prompt you like, "Hey, I'm about to do this. Is that okay?" But a lot of the other like the safety, the security, like I am not an expert. I really don't know. Like if I download Claude Code to my OS, what does it not have access to? I'm not exactly sure. So I'm in, I'm taking the approach of like, I don't know. I can't say everyone use these tools. I'm saying this tool is very interesting. Beware, be cautious. If you have sensitive data or sensitive information, sensitive hardware, maybe don't use it. A lot of it is kind of unknown to me. Okay, so let's keep going on the agents. One of the methods of how does an agent talk to software is through something called the Model Context Protocol or MCP. It was created by Anthropic, which is the creators of Claude, and they've made this open source and given it to the world. It's a standard communication framework, so an LLM can plug directly into all kinds of software tools, any software tool you can think of. And so here is my kind of illustration of what I think it is. So we have a computer here, that's the LLM, and we have a tool, and it's like we're just plugging it in like it's a USB stick. And the tool can be about anything. If you go to this URL down here at the bottom, that is a list of like all of the MCPs that exist. And so you're going to see huge amount of software where you can just plug your chatbot into. And if you go to ChatGPT or Gemini, usually they'll have a list of like connectors. Would you like to connect ChatGPT to your email or to your this or to your that? And so we're setting up a world where almost anything computing wise is going to be done or possible through English chatbot interface. So when it comes to geospatial, the MCPs of interest to you guys, perhaps first QGIS. Um, I assume ArcGIS Pro will have this capability soon. It's not an open ecosystem, so I don't know. You can also plug MCPs directly into Postgres, SQL databases, PostGIS databases, GeoServer, Label Studio, which is we'll actually take a look at in a couple weeks, which is how you make label training data for machine learning, Jupyter Notebooks. All these can just be controlled via chatbot. And some of that is amazing, some of it is terrible. Like so we're in this world where we're like we have this amazing tech, but we don't quite know how to use it. We're not sure like what the most productive use of it is. That's kind of where we're at, but it's wow, it's very interesting to see the potential. Okay, so I'm going to be doing this next week. And so the example that I've been playing with for several months now is um, plugging QGIS directly into Claude. And it's just like what you think. You're in a chat interface with Claude, and you've got QGIS on your other screen, and you can just ask it in just English to do things. Hey, bring a data layer into the GIS. Okay, now make a hillshade. Okay, now take that hillshade and clip it out based on this vector. Okay, great. Now make a map with this visualization and export it to a PDF or all of these things. Anything you can do clicking in QGIS, you essentially can do through a chatbot. And I played with this for several months, but there's still a lot I don't really understand about it. The technology is not perfected, and so you're going to see some strangeness. Sometimes it just doesn't work like you want it to. Other times you're just like, oh my God, how did it do that? So this is what we're going to be doing next week. So if you are interested in returning next Thursday, um, I have instructions on the course webpage of like what you would need to do to get set up. And so you would need to actually put this on your laptop computer. It's all free to do, and getting QGIS and Claude is all free. Um, with limits, of course. But yeah, if you'd like to come vibe code with me on QGIS next Thursday, please see the setup to do so. It's really kind of fun, and I would like to. It'd be really fun to have like a bunch of us all doing it just to see what all the results everyone gets, or like how reproducible is it, or like I don't know how it will turn out. It might just be total chaos, but should be interesting. Okay, so yeah, we will talk about Claude and QGIS next Thursday. Other geospatial agents. So Google is going hard into AI and geospatial. They really are. And in general, the comment is like the tech companies are coming for GIS and remote sensing. Most of us that are like kind of been in the university or government environment um, come from the academic side. This is all getting steamrolled by the tech companies. So yeah, Google, Meta, Amazon, people like that are coming very hard with all kinds of geospatial AI types of stuff. Um, so Google Earth, everyone's used Google Earth, right? It's a free app. You can scroll around and see anywhere in the world in 3 dimensions. And so they're adding their own AI agent, Gemini, to Google Earth. I have not tried it yet because it's not like open to the world, but I'm very interested to see what it does. So I imagine it's a text interface where you can do this, add this to the map, or do this analysis. Not really sure. So yeah, pay attention to that. Google Earth coming soon. Should have Gemini embedded in it. And then Google Earth Engine. Okay, so Earth Engine is not Google Earth. Earth Engine is a cloud computer where they have huge, mostly like raster imagery data sets. Think satellite imagery. It's a very unique, amazing platform, and they have an AI agent also. And so we're going to be doing this next week as well. So we'll do QGIS and we'll also do Earth Engine. Earth Engine also has some setup. You need your own account, you need your own cloud project. But again, it's free to do, but it does take some setup if you'd like to directly participate next week. And so, yeah, AI agent and Earth Engine. So again, through text interface, we can just tell it to do analysis, and hopefully it does it. Sometimes it does, sometimes it doesn't. It doesn't appear to be deterministic. Um, but it'll be fun if a bunch of us are all doing it together and kind of, we can poke at it and see what happens. All right, and then next is whole GISs are being reimagined as what I call AI native GIS. All right, so you now know that writing software is easier for everyone. People that are good at writing software now have like superpowers to write even more software. So I've noticed in the world of software development that there's 3 or 4 or 5 of these kind of new GIS type softwares out there. Usually they're just web-based and they are AI native. And so the whole thing is built around the chatbot. I have tried this thing called Mundi. Um, I did a little demo with it and it was to be like not my favorite because like they take away all the buttons and all the menus and all the things that you click on in GIS. They like let's take that all away and now everything is chatbot enabled, which is well, it's terrible. But you see the potential, right? So the pendulum is swung way out of proportion towards chatbot land. Um, and so, practicality, people will come to the senses and realize that there's some kind of happy medium where, yeah, we still need buttons, we need still things to click on. Um, but then the chat interface could help us do more tasks quicker, automate some of them like in a row, that kind of thing. So you could go to Mundi and try it out if you want to see if it's interesting. This is another one. It's called Monarca. It is I've not tested this one. It's I don't think they have like an open demo you can play with. You could reach out to them, maybe they'd let you play with it. Same idea, it's all kind of based on a GIS based around chatbotting, and I'd be interested to see if they've got the formula better, in terms of uh, what is chatbot and what is a button you can click on. Yeah, so check out Monarca and Mundi. Okay, we've reached another discussion moment. It is 10:40. Wow, yeah, we're gonna go more than an hour. Um, Anybody have any, quickly, any comment on agents? Anyone use them so far? Any thoughts before we move on to the next topic? Yeah, there's a lot of kind of ethical concerns and just yeah, bigger things to ponder when we unleash an agent to do things on our behalf. And most of it I've not figured out yet. I'm just kind of looking at this tech and going, that's fascinating. Huh. Yeah, thanks, Nate. Yeah, I haven't too much either. Please come next week and you'll kind of get the flavor of how they go. But this is active development. You know, these things aren't um, yeah, ready for prime time. Not going to replace, you know, how we're doing GIS currently at the moment, but you see the little sparks of potential there. Okay. Well, there's no other comments. Yep, still more of a copy paste. I am still a copy paste guy. Yeah. Yeah, I don't know if you trust AI companies. Yeah, I mean they are for-profit companies, right? They are they are there. Take your money. All right, so let's move on to a totally different topic. Related but different. Um, so let's move away from LLMs for a moment and then get into AI image analysis. Okay, or you could call it computer vision. That's kind of the term people use also. AI image analysis. So this has been a long march of progress for like 15 years. This is not something that just happened last few years. This is like a long, slow progress. You know, neural nets kind of invented and started really taking off kind of like 2011, 2012, 2013. That's when this machine learning or deep learning started happening on images. And over the years, things have just gotten better and better and easier to use. And it's gotten to a point where if this is kind of your thing, then a lot of you could start using deep learning models for imagery analysis. The pictures here of things, most of these things I have done myself in terms of identifying lettuce plants. Here I identified airplanes at the Tucson airport. This is segmenting trees. This is identifying trees along a golf course. I did not do these two here in terms of identifying damage to a house. You know, you could train an AI model to identify like a hole in a home, okay? Um, or identifying fruit in 3 dimensions. So what I've noticed is that if you could probably see it with your eyeball, chances are we could train an AI model to do something similar. I just want to show you a few things in kind of my world of high resolution and drone. This is a model called the Waldo model that they've trained to identify lots of different things from drone imagery, people, vehicles, jet skis, cars. Yeah, and so you can do it in still images. You can also do it in video because what's video? A video is just a whole lot of frames of still images, right? And so same technique can apply to video. So I think you get the idea. People, I know there's a kind of a creepy aspect to this. Should we be tracking people? Um, when people see this, so some of them start to think bad things about drones. And yes, this is not real time. We're not tracking people like as the drone is flying. We took some footage, we take it back to our computer, we analyze it, and we do it for peaceful civilian means. That's what we're doing. And so that model to do that stuff is just free. It's on the internet and anyone can use it. And so I took it, picked it up, and applied it to my own drone video. And so here I am tracking two people mowing a field turf plot in Las Cruces, New Mexico, and then also trying to track the cars. It doesn't work fantastic with the cars, but this was not a lot of effort. Like this, like the model already exists. I didn't have to make this from scratch. So yeah, so the idea with all this is that there's this collaborative open ecosystem where you can build on the work that other people have put out there. Um, yeah, and it is it's amazing what's out there. Okay, so when it comes to machine learning tasks, here's typically what we can train it to do. Let's say we have an original image of you know, a shrubland. We've got grasses, we've got some mesquite trees here. Um, these are just like the terminology of the final tasks that we can do. The first thing is called semantic segmentation. This is where every single pixel in the image is given to one class or another. This is typically how we would do things in remote sensing, image classification, right? Only we have a new name for it. It's called semantic segmentation. Um, we also have something called instance segmentation. So now we can distinguish different trees from each other, right? And so that allows us to count, for instance. Object detection, that's what I've been doing a lot of. It's the same thing as instance segmentation, only we're putting a bounding box around something of interest. And then finally, classification. And so in this, tech-driven machine learning world, a classification means you take an image and you describe what it is. And so classically, it was like you'd have a picture of a cat, right? And people would be like cat or dog or car or something. When it comes to geospatial imagery, you could call that a shrubland, or you could do it in a multi-classification way where you could say tree equals true. Yep, there's trees. Herbaceous equals true. Yep. Car equals false. So that's what we call classification, which is different than how we did classification kind of in the academic model of remote sensing. So yeah, so those four are kind of the things we can train a machine learning model to do. And how are we doing it? I probably need to glaze over this pretty quick. um, but we are doing something a bit more sophisticated than looking at an individual pixel or looking at grouping pixels and trying to identify what the group of them is. We're trying to more replicate what the human eye can do. The human eye can look at each of these different trees here, Palo Verde, mesquite, willow, and the human can very easily tell that those look like different species, right? It would be very difficult to train a pixel-based or an object-based model to do that. It just wouldn't work very well. But when we use neural nets, we can. Anything that the human can see easily, we can train with a little bit more effort, a way to identify them. The typical way is something called convolutional neural nets. And I probably should just go through this real quick because it's a bit complex. But the classic example is how would we identify a handwritten 9 digit? All right, how would we do that? How would we teach a computer to do that? Well, let's break it down to its parts, right? What includes a 9? Well, the 9 has this little loop here, right? This O or this 0. It also has this line, this vertical line, okay? Let's break it down even further. The loop is made up of corners and sides and little angles, right? So we can break down each element to its like further, small, tiny little components, right? And so what a convolutional neural net is doing, it's looking at all the tiny little components and then aggregating them all up to the big thing, like the 9 or uh, the tree that we're trying to find. So it's looking at tiny components, but then also aggregating it up to the big thing. It's looking at all of that to decide what the object is. It all starts with a convolutional filter. If anyone here has taken remote sensing classes, this is a moving window, right? You take a moving window. Do so. Okay, I'm back. Convolutional filter is a moving window, right? You're sliding the moving window across an image, you're doing multiplication, and you're getting a new image. This filter is finding vertical edges, right? It can go through a whole image, find all the vertical edges. So that ends up being the starting point. And so we can make hundreds of different types of filters to find vertical lines, horizontal lines, corners, angles, all these little tiny components. It all starts with these little filters, right? And then we can push them through neural networks to try to find the answer that we are interested in. There is a lot to learn about convolutional neural nets, and I'm not the guy to do it, but there's some great videos of how and great visualizations that you should check out if you really want to understand how they work. I'm not going to be able to do it justice. So this slide deck is available on the course content if you're interested in looking at some of these videos. So convolutional neural nets is kind of the old school. That's how most people do these computer vision image analysis tasks. Since about 2020, 2021, There's a new way to do it. It's called a vision transformer. And that is primarily how these large multimodal LLMs are doing their vision abilities. Again, a nice little video to basically give you a gist of how it works. We're not let's not play it. It's just going to confuse most of us, including myself. Um, so I take the approach that like I'm not a deep theorist of this. I'm not an engineer of this. I'm more of like a mechanic. I don't truly understand how a vision transformer works. I basically get it, but I know how to use it. I know how to pick it up. I know how to plug it in. I know how to get where I'm going. So envision. The thing that I want to impart to you all is you don't need to understand a car engine to drive one, right? How many here like truly understands every component of their car engine? I do not, but that's okay. You don't have to have great knowledge to be able to drive a car. And the same thing with using these machine learning models. We have to understand basically the inputs, the outputs, how the workflow goes. And so we're going to do a whole workflow in 2 weeks, an end-to-end deep learning workflow, to kind of just give you an idea. It's demystify it. So it all starts with data, right? Start with data. Then we have to tell the computer what we're looking for. We create labels or training data, and then we train the model using, this is all Python code. And then we create a model, right? A model is something, it's a piece of software that can be given to anyone. It's a little bundle of bits, and that model can be built upon, or it can be used directly for prediction. So I like to say that machine learning models are like Legos, right? They are modular, and there's often different pieces of it. So think of machine learning models like Legos, right? Legos are little building blocks that you can put together and build something. So that's what we're doing with machine learning models. Often there's a backbone or a base, a neck, and a head. The head is usually the part that does the final task that you're interested in, and it could be identifying the tree species. So yes, let's think of ML models like Legos. All right, and that Lego, the very base of it is all data, right? That's where all this all starts is data. Doesn't deep learning require massive training data sets? Yeah, yeah, the answer is yes, it does. However, that's been done for us. We don't need to start from scratch. And that's what a lot of people don't quite understand is that a lot of these data sets have already been made and we can just pick them up and use them for our purpose. Let me show you what I mean. So let's look at a few of these foundation data sets. So these pretty much come from the tech companies. Meta used to be called Facebook, has done an enormous amount of work in this regard. So I have to thank them for pretty much birthing this to the world. Um, so previously, kind of like the old school way, is that a lot of these foundation data sets were just pictures, like pictures from a cell phone or whatever, pictures of everyday things, not aerial imagery, not from a drone, a picture of a car, a motorbike, a chair, a person, a dog, a cow, right? So, and huge data sets. So the Cocoa data set is a very kind of foundational data set, 330,000 images, 80 different object categories. So all these object categories are labeled. Okay, so that's a foundation data set. It's kind of the start of the Lego building we're doing. Another very famous one is ImageNet. It's 14 million images. All kinds of different object classes are in it. And so the hard work in terms of that has already kind of been done, and we can build upon it for our own purposes. All right, so let's give you some example of how this works. There's something called a pre-trained model. Pre-trained model is when you take an enormous data set, you train it to do something, right? And then you have this bundle, a package that can just be then used anywhere as a foundation for whatever comes next. For example, there's the Cocoa data set, okay? And there is a product online, a machine learning framework, as you call it, or model called YOLO, which stands for you only look once. Let's say they looked at all this Cocoa data and they made a model to detect lots of things, right? That's the hard work. That's already been done for us. I don't know how to do that. I'm not going to try to know how to do that, but I can take what's coming next. So this YOLO detection model, and so my little network icon here means it's a model that someone can use. Okay, and then we can plug in some drone imagery, in this case, drone video, and you get to the Waldo model. And so Mr. Waldo, I don't know his name, he took the YOLO, added his own labels from drone video to make that video that you saw, when we first started talking about drone imagery. And he put that on the internet for free. Great. I took it, added my own drone imagery for my own specific people and cars that I'm looking for, and created my own model that I'm calling Jeff's Detector 1. So it all started long ago with the Coco data set. I had nothing to do with that, but I'm just building upon it. I hope that makes sense. Another example, there is a model called Detecto. Same thing. I started with Coco data set. I didn't make Detecto, but now they have this pre-trained model that I can just take and do a little bit of fine tuning and work for my own purposes. And so I took a few hundred images of an airplane, different airplanes, and then boom, I have Jeff's Detector 2, which is meant specifically to identify airplanes from airplane imagery. This was not a lot of effort. It was more, I had to understand how it all kind of fit together. Where do I find these pre-trained models? How do I write the Python to fine tune it? And then how do I apply it? And we're going to go through all of that in 2 weeks from now. But yeah, this is about just understanding the basic concept of it, that we don't have to start from scratch. We really shouldn't. And in the interest of time, let's just go by this. I had another example of deep forest. We will check that out in 2 weeks. So let's go right by it. How are we doing for time? 10:57. Okay, so we're coming up to the hour. There's some more I'd like to get through. So if you've hit your hour, thanks for attending. I really appreciate it. But I think I'm gonna keep rolling. Didn't know how long this might take. This will be recorded and posted to the course content if you need to jump off. So yeah, I'll make this available. For those who want to stick around, let's keep going. Okay, so we talked about the basics of a foundation data set, how we're using that to make pre-trained models, and those models can be built upon from other people. I can grab someone else's model, build upon it, and then boom, I have my own model that can work for my specific task. So what are remote sensing foundation models? It's very similar. So instead of the base being COCO or ImageNet, the base is entire satellite imagery archives, the entire Landsat archive, the entire Sentinel archive. Yeah, this has gone really crazy in the last 3 years, basically. People have realized that, oh, we can take all of the entire archive of satellite and train those first, and then hand it to people, and then they can build on top of it to do their specific task. So yeah, so some company or some academic group or someone smarter than me has taken huge satellite imagery data sets, made a pre-trained model of it, and then put it out on the internet for free for people to use. And so me, I can take a little small data set. So maybe I want to identify trees or, yeah, okay, let's identify forest from Landsat imagery. I have a few hundred labels of what a forest might look like from Landsat imagery. That's my small little data set. And I can do my little fine tuning, my little training, and then boom, I have a model that can identify trees or identify forest from Landsat. So that's the idea. The idea is that we can build upon each other's work and we can collaborate across the internet to do so. And so these remote sensing foundation models are really starting to take off. I see like a new one like every other week. For instance, there's something called the SATLAS pre-trained models. They have individual foundation models that are made from Sentinel-2, Landsat 8-9, or even NAPE imagery. And so those are 3 different models that you can just pick up for free and use, right? It uses transformers as the background and also CNNs. So those are the 2 types of AI neural nets we're doing for imagery. Okay, so yeah, this link takes you directly to their page. And you can just take their model, apply your own little data set for your own specific task, and then boom, you're in business. There's one called Clay. And so Clay is trying to do an all-in-one approach where they take Landsat, Sentinel, NAPE, MODIS, and throw it all into one model. um, and then they put it out to the world. And so what makes this possible is that these models are not generally don't have labels. Some of them do, some of them don't. Some of them, they have something called self-supervised learning, where it's learning like what things look like in the landscape, how images are related, what images are, but they're not necessarily labeled. Like they're not necessarily training it to identify a tree or a forest or something. So they're able to do huge amounts of this pre-trained models because it's kind of automated. There's another one called Earth, um, and they are going beyond just satellite images. So they take satellite and then they take radar and elevation maps and climate data and land cover and any other kind of global data layer you can think of, and they're putting it all into one gigantic foundation model. I mean, I can't really tell you what does that mean exactly. I've not actually done it. But yeah, when in terms of like, what do you mean elevation or land cover? Like, what does that mean? So, yeah, I guess the idea is if you're trying to do land cover yourself, you've gotten 90% of the way there because of how they pre-trained these models. I don't know, it's kind of unknown to me. Google's come out with a foundation model called Alpha Earth, which I would check out. Alpha Earth. Maybe you could put that, Google that, Carlos. Alpha Earth. That's from DeepMind, Google's DeepMind. Same idea, satellite imagery, and I think other data products as well. But the idea is that here's this massive data set, pre-trained model, and you take it and add your own little data set, fine tune it to do something specific. Okay, so the open machine learning ecosystem. Like I said, most of the software I use, most of everything I do is just free to use, open for the most part, and it makes it really powerful. So there's me at my desktop, happy. At least at that moment, I'm happy. Not always. Um, and what are the tools we're using? We're using Python. Python is an open source, free for anyone to use language, right? That is the language of machine learning is Python. And the LLMs are incredibly good at writing Python. PyTorch is the Python library to do the neural net training and prediction. And this was created by Facebook Research. And so they've given it over to the Linux Foundation. So it is now like it belongs to the world, basically free and open source. And it all came from Facebook. So PyTorch is the thing that's really the software behind a lot of the AI revolution. Label Studio is a free software to do your labeling. Like here's all what all the trees look like. And yes, you can do that in like ArcGIS or QGIS, but things like Label Studio like are really made for it. And we will give a demo of that in a couple weeks. And then how do we do this collaboratively? So there's a website called Hugging Face, kind of a silly name. But this is where you're going to find a lot of your pre-trained models, right? A lot of your training data sets. So Hugging Face is kind of the hub, the online hub for people that are in machine learning. There's all kinds of things to find there for free. And then the other obvious one is GitHub, which is Hugging Face and GitHub are similar. GitHub is mostly for code examples, sharing software other people have made. And Hugging Face is specifically for machine learning models and data sets. And so the combination of all of these things, all basically free to use, um, gives you an enormous power to do a lot of interesting image analysis. And yes, there is a learning curve. You know, I can't sit here and say, oh, this is super easy. Anyone can do this. Not true. There's a lot to learn, but it's all there if you're interested. Um, and hopefully I'm giving you a little intro, a little demo that might spark your interest. So to get started, we do have some existing kind of pre-baked Python that I have done. I'm working on these right now, and we'll be doing these in a couple weeks. So there's something called Deep Forest, which is about identifying trees. There's something called Detecto, which is identifying anything. You can train to identify anything. There's the Waldo drone video that I showed early. All of those things I have kind of free code examples of how you might do that on GitHub. Um, I haven't looked at some of them in a while, so they might be broken, but it's a starting point. So again, if you're really interested in like how do I do this machine learning workflow, we're going to be doing that in a couple weeks. So here's the schedule for the rest of the time of this workshop. Again, next week we're doing coding agents in QGIS and Google Earth Engine. Please check the course content. Again, Carlos, I think you put that in the chat of what your setup is. There is some setup. If you don't want to do any setup, you just want to show up and observe, that's fine also. But it'd be really fun if you actually did the setup and then we can, start doing some agentic stuff together. In 2 weeks, so September 18th, I will do this end-to-end deep learning thing. And for people that really want to participate, please reach out to me specifically because I'm going to set up a virtual machine for every single student that wants one, and that takes preparation. So if you really want to participate and do machine learning workflow, you need to contact me. Um, you can get my email from the course content webpage. Please email me so that I know how many people to actually expect to do that. Other than that, there's no setup. I will be giving you a computer. You need to have your own laptop so you can tap into it. But we're going to be using something called Jetstream 2, which is a cloud computer at the University of Indiana, and that should be fun. We will have 20 people each on their own virtual machine doing machine learning with their own GPU. It should be a fun time. And what else? How much time do we got? It's 11:08. I've got more if people want to stick around. Got some more. Um, okay, let's see if we can get through this real quick. So, kind of the last thing I wanted to show you is something called vision language models. And if you ever use ChatGPT or Gemini, maybe you kind of understand where I'm going with this. Um, ChatGPT, a lot of these multimodal LLMs are trained with imagery, text, all kinds of different modalities of data, right? And so they understand how to relate text to image or image to text, right? They can go back and forth. So if I ask ChatGPT to create me an ancient map showing the way to the 7 cities of gold in the New World, you get something like this, right? So for an AI to make this, it has to relate words to images, and that's what these multimodal um, models are doing. Okay, so that's kind of the start of these vision language models. Another example, I uploaded a drone image of a golf course. So this is Paradise Valley Country Club up in Phoenix, and I'm asking ChatGPT to just describe what it sees, right? And it gives me this answer. It knows. My God, these AIs can read images really well. They know what they're looking at. They see a golf course, they see a residential area. Do they even mention, yeah, they mention a swimming pool. So this is all done through vision transformers. So just the AI models out there, Gemini, Claude, ChatGPT, have amazing image, vision to text uh, abilities. And I've barely kind of scratched the surface of what these models can do, but very clearly they can do a lot of interesting image analysis just out of the box, right? And so that same concept is being applied directly to geospatial data, satellite, airplane, drone. We can do the same thing. We can connect text, words to images. Show me the swimming pools. And so Qisheng Wu, who is a pretty renowned geospatial guy at the University of Tennessee, has a Python library where you can do that. directly. You can just give it words. Show me buildings, show me trees, show me swimming pools. And behind the scenes, it's using a segmentation model called Segment Anything. That's also from Meta. And then something called Dino, Grounding Dino. And so Grounding Dino is the vision language model. And so it's using two different AI models to go from show me swimming pools to actually finding the swimming pools on the images and then, you know, uh, putting a box or a mask around it or a segmentation around it. And so I'm seeing this concept pop up more and more in different software, this vision language. Can we chatbot our way through remote sensing and image analysis? It seems that the answer is yeah, we're going to be able to. Um, how great is it going to be? I don't know, but clearly the building blocks are starting to be there. There's a website called GeoNator, which is specifically hosts and analyzes drone imagery. I have my entire drone archive on GeoNator, and they have the same thing. You can give it a drone image, and I can be like, show me the houses, and it will segment it and things like that. It's not perfect. Like you're going to see that, it kind of works, right? So, we're still in the early phases of figuring out this technology. It kind of works, sometimes not. It's not something I would depend on, but you see the little sparks of magic. Like, oh, I see where this is going. That can I chatbot or English text my way to remote sensing image analysis? Yeah, and I use the word queryable Earth. This was coined by can't remember his name, but he was the CEO of Planet, the satellite imagery company, some years ago, back in 2018. I think he came up with this term queryable Earth. And at the time, I was like, what? And so, yeah, he foresaw that we'd be able to text our way or prompt our way to doing image analysis. Here's another platform you could try. It's called Clarity. It's another one of these kind of AI first web GISs. And it's just that. It's like, show me this. How many trees are in this image? Again, it's early days, but again, you kind of see where it's going. That people are starting to build image analysis and GIS all chatbot based. Um, and yeah, no, we have new tools to check out. Okay, so we're almost done here. 11:13. Where is GeoAI headed? Okay, I'll play. A, yeah, this is a Google marketing video. Basically, let's see what it tells us. No, it didn't play, did it? Okay, let's not play it. So geospatial reasoning. If you're interested, check out this URL here. Google is trying to see the future, right? They have their Gemini, their multimodal LLM, and they know that they can control GIS. They know that they can probably control image analysis, and so they're heading to a world where through a chatbot and agents, it will connect all the pieces together in terms of automation. And so you can see the vision is kind of towards high autonomy. I don't know what this looks like exactly, but think about like you could do a little query like, "Hey, I'm interested in what's the forest cover of northern Arizona?" Okay, and instead of having to find all those pieces yourself, it finds the pieces. It goes to its image archive, gets the image archive, does the image analysis, presents it to you. And so like, all these kind of deep autonomous things where it's connecting a bunch of tools together to do geospatial stuff seems to becoming a reality. Um, where's it going? I don't know. How good is it going to be? I'm not sure. If you've ever used deep research with Gemini or ChatGPT, each of them have a tool called deep research, where you send it on a mission to do a literature review or market research, and it goes off for 20 minutes and then comes back and it has done all this internet research and it gives you like a perfect report. And so it's going to be doing the same thing with geospatial. So yeah, I'm kind of excited to see where it's going. Um, I imagine the whole machine learning workflow to become automated. Right? So this is a machine learning workflow. We uh, we take a model, we run it on our imagery. Did it work or not? We do some labels, we do some fine tuning and training. We rerun the prediction. Did it work better? We assess the quality and like around and around we go. How do we make our machine learning models better? Right? Right now, I'm doing that in a very manual way. Like each of these steps, I'm like, okay, I need to write my code to do that. I need to do the labels. I need to write code to do the fine tuning. I can imagine a very near future where this whole workflow of machine learning is just automated and you just send the agent out to do it. You're like, I'd really like to create a salt cedar detection model from airplanes. Can you help me with that? Oh, sure. Yeah, let me just find the data set, do the labeling might be the hardest part. um, but it seems like we're on the cusp of this to be automated, so let your imagination go wild. If an agent is autonomous and can do anything you can do, where could that lead in geospatial? And then I was just at AGIC. Yeah, I was just at AGIC, which is the Arizona Geographic Information Council conference last week, which is kind of the state meeting for all the GIS, the spatial people in Arizona. And each year they have what's called an Iron Cartographer contest, where they have two or more people up on stage, like making maps in real time. It's like a mapping competition. I think with a timer, like, okay, you have 1 hour, go make the best map you can. I'm thinking next year maybe I will enter my AI and see if I can win. Probably won't win, but like you can see the little sparks of like probably not too far off that I can make a really beautiful map through QGIS or whatever, all just through chatbot prompting. So that seems like that's kind of where some of this is headed. And that I will end it. It's 11:18. I went a little over. I will take any questions or any comments anybody has. Um, so again, plug next week. So next Thursday, same time, we're going to be doing QGIS and Google Earth Engine using agents. And so there is some prep if you would like to directly do it. So please check out the course website. It should be in the chat. And then in 2 weeks from now, we're doing a full end-to-end machine learning workshop, or everyone is going to have their own virtual machine. So if you're interested, you please reach out to me. Here, I'll put my email in the chat. Let's see if this works. Okay, people see that? jgillen@arizona.edu. If you'd like to participate in this deep learning workshop, please let me know directly so I know to like have a spot for you. It will be limited, maybe up to 20 people or something, but like you need to be kind of serious if you really want to do it. Please let me know. You could just observe. You just want to, stop by and check it out. That's fine too. But if you want to participate, please let me know so I can prepare. And that's it. Thank you guys very much for attending, and hopefully we'll see some of you, a lot of you, in the coming 2 weeks. So any questions or comments?